So thinking about this one, number 21, what do you feel would be a good U substitution?
Probably the E sign. I don't even know where to start.
Yeah. Well, the only thing you know, the only thing you know is how to integrate e to the u, right? You know the integral of e to the u is e to the u. That's our favorite one because it is its own. So you really hope that you can make a substitution so that all you're left with is e to the u,
Okay.
right? So for that to happen, what would u need to be?
Sine.
Inverse sine. That's a sine to the negative one. Okay, so that's inverse sine. So let's just try that. Let's say let u equal the inverse sine of x. All right. Now, du means what is the derivative of the inverse sine of x? Now, you may not remember this, and actually I don't. Do you have your integral sheet?
Not with me.
Okay. I promise you that it is going to be exactly 1 over the square root of 1 minus x squared. If you look on your sheet, it is this, and it's just wonderful that that is the case. And then you're going to have a dx. Okay, so you would want to have your sheet with you so you know. But that the inverse sine functions have these interesting derivatives, and you learned about them in Cal 1, but maybe you don't have them memorized. So look at that. This is exactly that, right? So that means that by making that substitution, you're immediately able to write this as the integral of e to the u du, right? Which means this is, we know the integral of e to the u, it's just e to the u plus c. But what was u? U was the inverse sine of x. Yeah. And then if you were to take the derivative of this, you would get back to that.
Okay, yeah.
And it would just be a chain rule. Pardon?
That's easy enough.
Yeah. So these little, it's all you have is the u substitution at this point, but it is a good, kind of a good little tool. And